Hi, I'm Miss Taggart. In this video, we're going to have a very quick recap of all the scientific notation things we were taught. So first of all, quick recap of what scientific notation is. It's another way of writing numbers a lot smaller, and it generally takes this form here, where it's something times 10 to the power something. Now the bit at the front that's getting multiplied by 10 to the power has to be between -1 and 0. So if you had a number like 3,200, the decimal point would go in here. It always goes in after the first number, and that way you're getting a single digit number that's between -1 and, sorry, that should say a 10 there, not 1. So it should be between -1 and 10. So for example, it can't be 0.32. It can't be 32, so you use 3.2, and that's what that means, okay? Secondly, the power n is how many places that decimal point moves from where it was to where you are putting it. So in this example down here, my decimal point isn't obvious, but it is hidden here, and it would be moving 1, 2, 3 places to there. So the power on this one would be times 10 to the power 3. Now, a little thing to remember, if it was a big number like this one, so if it's a number that's greater than 0, like 3,200, it's a positive power. If it was a number that was less than 0, for example, 0.3200 to start with, that's classed as a tiny number, so that would have a negative power on it. So let's have a look at some of these. So first couple of examples, writing these in scientific notation. So the decimal point goes after your first digit, so it goes there. So this gives us 7 times 10, and then the power is how far it's moving from its place where it's hidden from there to there, and you can see that's moved 4 digits, so it's a power 4. On the second one, the decimal point is going to go from here to in there, so the multiplier bit is going to be 9.2 times 10, and then the decimal point has moved 3 places this time. Please note, it is not the number of zeros, it is the number of digits it is moving. Number of places it's moving from the end to where you're putting it. I know there was 4 zeros in the first one, but it's not always the case like that. So they were called your big numbers. Then we had the tiny numbers, so these are going to have a negative power, and your decimal point is moving in opposite direction this time. So it's going to go after the 6, so it's going to be 6 times 10, and then we have moved that 3 places, so that has got a -3 on the power. Also notice how many zeros at the start of the number. 1, 2, 3. That's the wee trick for that one. On this one, the decimal point is going to go after the 8. So it is going to be 8.23 times 10. And then it is moving from here to here. So that is, sorry, it's moving from here to here. So how many places is that? That is 5 places. So power -5. Also 1, 2, 3, 4, 5. 5 zeros at the beginning. So that's your writing in scientific notation. Let's do the reverse and put them back into normal form or in full. So remember, if what I said, if it was a positive power, it's a big number, and it was a negative power, it's a wee number, okay? So this is a really big number, and that means we're basically timesing by 10 7 times over. I'm moving the decimal point from here 7 places. So in this case, I'm just adding 7 zeros. So this is 9 with 1, 2, 3, 4, 5, 6, 7 zeros. So that's really 90 million. On the second one, you write out the 173 first of all without the decimal point. Now the decimal point has already travelled 2 places there to be after the 3. We wanted to move it 5 places. So if we've already moved 2 and we need to go 5, that means I've got 3 zeros to add on. And you can always do a quick check of your answer. From the 1 to the end of the number, there are 5 places which match the power 5. So you can always check by trying to multiply it back out. Okay, my next one is tiny numbers. So that's denoted by the -4. Now the trick with this one was the decimal point had to move that way 4 places, which can be a bit tricky. But remember what the trick was, that one? -4 meant you had 4 zeros at the start. So you had 0.1, 2, 3, and then 8. And remember that thing about a quick check, I can check that goes 1, 2, 3, 4 to there. So I know I've got the right answer. Next one, -6. Use the trick with this one, 6 zeros. So 0 point, there's 2, 3, 4, 5, 6 zeros all together, and then your 6, 5, 4, 3. So that was writing them out in full. So then after that, I showed you how to do notation on a calculator. So a quick reminder, Most calculators use these two buttons here that I've got highlighted down the bottom. Sometimes if you have a calculator that's maybe a bit older or not a Casio, this button might appear somewhere up around this row if you've got a slightly older calculator. So it's either times 10 to the power x, some have got times 10 with a wee blank, or an EXP button. And that does the whole times 10 to the power bit. So let's have a look at this. One other thing I might point out is that this is your negative button here. Some calculators might have one that says a plus and a minus as well. Okay, so to do this one on your calculator, this is what you're going to type in. You are going to type in the following: 6.74, your times button, and then that button I pointed out to you, whichever one it is you have, I'm going to write times 10 to the x, and then you would put in the 8. So that is the first part of the sum. Then you would hit divide, you would hit the button number 2, then you would hit that special button again, and then you would hit your negative button, which I'm going to write like that, and then I would hit the number 3, and then I would hit the equals. So I'm sorry that's going a wee bit off. Now when I typed that into my calculator, I got this number. I got 337 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. I kind of hoped my actual calculator would have put that into scientific notation straight away for me. If yours does, brilliant. So this gives me 3.37 times 10, and I know I had 9 zeros to there, plus another 2 is the power 11. Okay, so that's just a wee recap of all the kind of scientific notation stuff we covered. I hope it's helped.